How are we doing, guys? We are looking at chapter 8.3, page 245, 248, and we're going to do these four questions here. But first, we're going to introduce ourselves to this term, injective and surjective. So if we look at this function, x plus 5, I've expressed it two ways. One with the mapping diagram with the domain of 0, 1, 2, 3, 4, which means 0 plus 5 is 5, 1 plus 5 is 6. Here's our range of 5, 6, 7, 8, 9. And once over here on a graph, and this obviously is with a continuous set of input values. So it's the real numbers here, whereas we're looking at natural numbers here. So slightly different in terms of our inputs. Here are the real numbers, whereas here they're the integers between 0 and 4. Either way, it's a linear function. And what do we mean by this word injective? Well, injective is, or one-to-one, it means every output, such as 8, corresponds to exactly one input. Okay, so that's an injective function, as opposed to down here, this function y equals x squared, where 4, well, that corresponds to two different outputs. So that is not an injective function. So injective function are one-to-one. Every output has exactly one corresponding input. Or the other way we'll sometimes talk about it is with this horizontal line test should cross no more than once. Okay, if it crosses 2 or 3 times, you're not looking at an injective function. So down here, it's not injective because that horizontal line, y equals 4, crosses twice. Now, it doesn't mean that the horizontal line has to cross. So for example, if I restricted my domain here to only the positive integers or the positive real numbers, well then a line through here would not necessarily cross the function, but it would not cross it more than once. So that would be acceptable. You would say, yes, that is an injective function, because a line through here, for example, would only cross my function at one point. That is where I've restricted the domain to say we're not allowing any x values less than -1. Okay, so there's the second function with this domain -2, -1, 0, 1, 2, and a range of 4, 1, 0, 1, 4. That's going to allow us to talk about this idea of a surjective function or an onto. So one-to-one and onto are the sort of less formal versions of injective and surjective. It's when the range and codomain are equal. That is, every output gets used. So here we have a function where the range, if we're talking about real numbers, is 0 to 4. Oh, sorry, 0, it's all the real numbers that are greater than 0. However, the codomain would be all of the real numbers. So here, the range and codomain are not the same. And another way of saying that is the horizontal line should only cross once, or should cross exactly once. That is to say, everything on the range, sorry, on the codomain, excuse me, should also be an element of the range. So that is not the case here because, for example, -1 while being on the codomain is not on the range. Up here, assuming this goes on forever, well then actually every value on the y-axis does get used, and any horizontal line I might draw would cross exactly once. So for this function up here, yes, it is surjective, okay, because the range and the codomain are both equal. That is, in this case, they are from -4 to 4. If I want to make this function surjective, I could restrict my codomain, and I'd say, well, f of x needs to be greater than 0, and then in that restriction, I'm changing it into a surjective function. Any function which is both surjective and injective is called a bijective function. Okay, and when we look at inverse functions later on, we'll see that we need a function to be bijective if we're going to find its inverse. So this function up here, which is both injective and surjective, is also a bijective function. And the way you know it's bijective is that horizontal line crosses exactly once. Okay, so injective, it has to cross no more than once. Surjective, it has to cross at least once. And bijective is when it crosses exactly once, a horizontal line. I've got another function here. Excuse me, y equals x cubed. So with this domain, first of all, the mapping diagram I've done, just obviously for the integers, you don't do every single real number because that's impossible. minus 3 cubed, minus 2 cubed, minus 1 cubed. Okay, so here's my domain. Here is my range. My codomain is all of the real numbers on the y-axis here. And if I was to do that for the real numbers, so if I was to make that a continuous function and join up all these dots on my graph, this is the shape that I get. So is this function injective? Well, any horizontal line I draw, or there's no point where I can draw a horizontal line that will cross more than once. So that is, each output, like 18, corresponds to just one input. So yes, that is an injective function. Is it surjective? Well, everywhere I might draw a line, and these go on forever, will cross the graph at least once. So yes, it is surjective. Or another way of saying that is the range, which is all of the real numbers on the y-axis, is the same as the codomain, which is all of the real numbers on the y-axis. Therefore, is it bijective? Well, yes, it is, because any line I might draw will cross exactly once. There's no line I can draw that will cross more or less than one time. So that is a bijective function. Okay, so let's have a look at question 1 here on page 245. Question 1 says, state whether the following maps are functions, if they're injective or surjective. So remember, a function, every input should only correspond to one output. So each of these inputs only has, say, one line coming out of it. Okay, so we can kind of say, yeah, that's a function. Same thing here. We haven't got any one input that corresponds to, say, two outputs. We do, however, have these two outputs that correspond to an input. We'll talk about that in a second. But yes, both of them are functions. Are they injective? So injective means every output corresponds to just one input. So no, not the case here, not injective. Over here, yes, each of those outputs only corresponds to one input. So that is injective. Are they surjective? Well, here our range is 1, 2, 3, 4 dots, but our codomain is 5. So no, not surjective. Whereas here our range is these 5 dots and our codomain is also those 5 dots. So yes, surjective. Why is function G bijective? Well, because it is both injective and surjective. It falls into both of those. Question 8. The graph of a function f, where its real numbers being mapped onto real numbers, is shown on the right. What is the range of the graph function? Well, the lowest point there is -1. So the range is f of x is greater than -1. Okay, the numbers, all of the output numbers are greater than -1. The codomain is, actually, to go back to this notation, -infinity to infinity. Okay, so maybe up here, the correct, or to be consistent, you might have said, well, that's from -1 to infinity is the range. That's the codomain. By comparing the codomain and the range, explain why f. So the codomain, remember, is all of the possible outputs. Why f is not surjective? Well, because the codomain and the range are not equal, and in order to be surjective, you need an equal range and codomain. Suggest a restriction on the codomain to make f a surjective function. Well, we need to take this codomain and restrict it to, well, you'd say you can't put a -2 or a -3 in there because that won't allow us to pass our vertical line test, our horizontal line test. So a restriction would be, if the codomain was for f of x has to be greater than -1 or between -1 and infinity, you might write it like that. That's not coming up too clear, sorry about that. Okay, use the horizontal line test to show that it is not injective. Okay, well, if we cross the horizontal line, it strikes it twice, so it is not injective. Suggest a restriction on the domain to make it an injective function. Well, if it just went from here up, then it would only cross, any horizontal line would only cross once. So if we can get rid of this bit, we'd say as long as x is greater than 3, okay, or if we were to say the domain has to be between 3 and infinity, okay, 3 being at that lowest point, then we're away with it, okay, because then the graph only has one increasing element, let's say, in any horizontal line I cross would only cross here. This bit doesn't exist. It's question 8. Question 10. Use the horizontal line test again to investigate, is the given function injective? Well, no, because you can cross the function 3 times with one horizontal line. Surjective? Yes, because anywhere you might draw a horizontal line, the function is crossed. Is the function bijective? No, because it is not injective. And finally, question 11 here. Explain why the graph on the right does not represent a function while our vertical line test crosses it twice. Okay, so 2 as an input has 2 possible outputs, so that is not a function. Suggest a restriction on the range to make the graph a function. Well, if you said f of x has to be positive, so you ignore this bottom part of the graph, that function there, that's absolutely perfect as a function, or that part of the relationship is perfect as a function. So f of x is greater than 0, or you might say it has to be between 0 and infinity. Okay, what I'd like you to do now, please, is questions 2 and question 6. And we'll talk about that more in class tomorrow. Okay, bye-bye.